Greetings, Houdini Python students. This is Chris Rhoda. The next lesson is a two-part lesson delivering an introduction to the Houdini node class. Now, this is the base class for all of the nodes in Houdini, such as objects, SOPs, COPs, POPs, ROPs, or what have you. And all the node types that you're ever going to deal with in Houdini will inherit the methods discussed in this lesson. Now, just as a warning, the Who.node is a reference to an actually Houdini node. And whoops, the documentation is making an entrance. Okay, the Houdini node and the Who.node are not exactly the same thing, and their lifetimes may be different. In Houdini, a Houdini node can certainly exist apart from a Who.node, but however, a Who.node references a Houdini node which may be deleted. And any sort of access to that Houdini node, once it's been deleted, will trigger an exception. And as a reminder, the full documentation for this class can be found in the help page under Who.node, and this can be very, very helpful. So I'm going to keep this tucked away down here. Now we're going to launch right into our Python shell and go right into our normal course of things. And what I'm going to do is create a new node for this large character that we have here. I'm going to call him ToonGuy. And I'm going to drag and drop the node onto there. So we have the node equals ToonGuy. Now the first method is one that you've seen before, and it's the name method. So I'm going to type print node.name, and we see it's tune.guy. Now if we wanted to do the path method, we've seen that one before too. Node.path, and it prints out the path value for this. Now if we wanted to actually change the name from the Python shell, we can do that as well and use the set name method for that. So I'm going to say node.set name, and I'm going to call this tune dude. Okay, so we have a new name for this, and notice that the name of the object did change from ToonGuy to ToonDude. Now the next method is called the node method, and this returns a node, whether it be the absolute or relative to the current node. And for this, I'm going to need to get a more sophisticated place. So I'm going to say create a new example. I'll say foo equals this particular node right here. Now we can actually get the node information of any node, whether it be absolute or relative. Now what do we mean by that? Well, we see that ball node down here, and that's an example of an absolute path. So I'm going to say print foo.node, and I'm going to give the absolute path. In this case, it would be object ball.path. And so what this is going to do is print the ball object, which is an absolute path. Now, what if we wanted to do it relative? Like we wanted the parent of our current node here. Well, we print foo.node, and we go to the relative position, and dot is means move up one level or give me the parent information. So I'm going to get the path information of the parent. And likewise, we can do it with a sibling. But instead of the parent, we're going to have to go into the parent's children again, and I'm going to type in head and neck. And so I'm going to get the path of my sibling node, path and head and neck. Now, if we wanted to do the actual child of this node, we can do that as well. So I'm going to create a new variable. It's called skin equals, I'm going to create a child of it, and I know it's called skin, so foo.skin, foo.node, and the path of that, or the name of that, is skin. Okay, we now have a new variable called skin, and it's referencing the skin variable, or the skin node, which is a child of that. Now, if we look under here, the skin node actually contains a whole mess of nodes in its as children. And so what we can actually do is, like, suppose we wanted to know all of the children that skin actually has. Well, children is a method that returns a tuple of all the nodes that are children of that node. And for that, we're going to use a for loop, because there are going to be a lot of kids in here. So kid equals, whoops, for kid in skin.children. All right, I'm going to go ahead and print out the name of each of the kids. And we see a very long list of all of the children that are inside of that node. Now, likewise, if we wanted to know what the parent of that is, we could just print that out. Print skin dot parent, and it's going to give us the name of the parent rig, which is tuned to form rig that we got before. Now we can actually go and, instead of moving around, we can actually use Python to create a node of the child that we want. And so we're going to create a variable for this ball node. So I'm going to say ball equals, I'm going to drag and drop this node onto here. Come on. Here we go. All right. Now what I want to do is add a new object here to go into my ball node. And we do that by the create node command. And a create node method creates a new node of type node name type as a child of this node. And say, okay, what's a node name type? So we're going to give an example. I'm going to say box equals ball dot create node. So create a child of it, and I'm going to give it a type of box because I want a box type for this. I'm going to call this guy new box. Okay, as we see, we created a brand new box object here. However, we can't see it because it's not connected in the output node, but I'm going to basically jump onto the output node on this, and we see that the output changed from a sphere to a box object. So we do know that the new box object was created successfully. Now, if we wanted to destroy an object as well, then the command is destroy, or the method is, and we want to, suppose we want to destroy this new box object. I'm going to go box dot destroy. Did I spell that right? Yes, I did. And the box goes away. The boxes have been destroyed. Now, if I wanted to print the name of the box object, once it's been deleted, it's going to give me an error. It says the object was deleted and attempt to access the object and no longer exists in Houdini. So this is the exception. So I'm going to go ahead and undo that deletion so we'll have it before. Now what we could do is, suppose we wanted to know if an object was selected or not, or if we wanted to control that selection process. Well, we could do that by using the set selected or the is selected command. I'm going to say ball dot set selected. And the input for that is a Boolean, so I'm going to say set selected is true. And so what happened is that Houdini went ahead and selected that object. If we wanted to deselect an object, we just give it the Boolean value of false, and the object is now deselected. And if we wanted to test that to see if whether it's selected or not, we can use the is selected and return a Boolean value, which will identify if this object has been selected or not. And it returns false, which means it's not selected. Now, we use the node create command to actually create, but we need to know the node type. And to get that information, we might actually have to dissect an actual node and find out what type it is. And the type method is the method used to create that. And so what we wanted to know is, suppose we wanted to find the method for the, or the type of ball. What we'd use is the type method. And we say print ball dot type. Now type returns the Houdini node type object for this node. And remember that a who.node type is a data structure. That what we want is the string associated with the data structure and not the actual data structure. I'm going to put name in there so we get the name associated with that. We find out that it's called a geo node, and we might use that again for future reference. Now, in the next lesson, we're going to continue with our exploration of the all-powerful who.node superclass. I'll see you during the next lesson.